Most often when we're dealing with significant digits in terms of measurements, it'll be in the form of a measurement that's already been done. It won't be that often that we will actually have to do a measurement. We will just need to know how many significant digits are present in the number that was given to us. That becomes important later on when we go to do mathematical operations, because in the end we can have no more significant digits than what we started with. Significant digits in terms of non-zero numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, incredibly easy. If you have a non-zero number, it is significant. The question comes with zeros, and there's a few different situations that we're going to go through in these examples to illustrate exactly what the difference is between zeros in one position versus a different position. So example 1, 96 kilograms, we have two non-zero digits, we have two significant digits. Example 2, now we have zeros in a leading position. Those zeros are there to place the decimal so that we know we have 0.000783 liters instead of 783 liters or 7.83 liters or something like that. Those zeros are necessary to make the number what it is. So those zeros, because they are necessary, they are not significant, so we do not count those. We only count the 7, the 8, and the 3 to give us 3 significant digits. Three, again, we have all non-zero digits. They are all significant. We have 3 significant digits. 4 is the exact opposite of 2. Now these zeros are trailing. They're at the end. Again, what you can ask yourself is, do I need these zeros to make the number? Well, could you say that without the zeros? Yes, you could. So those zeros were a conscious choice to put in the number. Why would they be put in? Depending on the measurement device used, if you were using a meter stick laid end to end to measure kilometers, I know, kind of a silly thing to do, but if you did that, you would be able to read the meter stick to at least centimeters, if not millimeters, so you would be able to get a more accurate measurement. These zeros, because they are at the end and also after the decimal. That's a key thing. Zeros at the end, but must also be after the decimal, do count as significant. So this number has 5 significant digits. 5, again we have a 0, but this 0 is sandwiched between 2 non-zero digits. Now this is where my explanation with number 2 kind of breaks down a little bit. That 0 is necessary, but because it is sandwiched between 2 non-zero numbers, it is significant. So that number has 3 significant digits. Anytime a 0 is sandwiched between significant digits, it automatically becomes significant as well. 6, we have the exact same situation as 5, a 0 that's sandwiched between non-zero digits. This has 4 significant digits. Seven again is kind of like 4. We have a 0 that is at the end and also after the decimal. That 0 is a conscious choice to put in. That 0 is significant. 3 significant digits. 8, again, we have all non-zero digits. They are all significant. 3. 9, we get into the final situation with 0. These zeros are at the end, kind of like 4, kind of like 7, but they are not after a decimal. Those zeros become necessary to make the number 7,000. If we didn't have them, we might have 70 or 7. Those zeros are not significant. We have 1 significant digit. Number 10. The exact same number as number 9, and no, that is not a blob on the page, that is actually a decimal point after 7,000. In this case, by putting the decimal point in, we have made an exception to the significant digit rule. By putting the decimal in, we are saying, yes, these zeros are significant. It's unfortunate that it worked out to the number 7,000 instead of 6,984, but that's what it was, and we need to make that exception in this case. So this has 4 significant digits because of the decimal point after the number. This is not the only way of showing that those zeros become significant. I could also give you the number as 7,000 grams like this, with a line over the last zero. That line is not like math. When you put a line over the number in math, it means that number repeats. This just simply says that that zero specifically is significant. So the 7 is significant because it's non-zero. The 0 at the end of the number is significant because of the line over the top of it making the exception. And then automatically the 2 zeros in the middle, because they are sandwiched between 2 significant digits, they automatically become significant as well. So in that case, when we have an unfortunate situation of zeros happening to be in the number, we sometimes need to make the exceptions, and those are the 2 ways that we can show it.